Hello everyone, this is an analog questions which was asked in the year 2017, and I found this question is a very basic one, and it requires the application of the concept from many topics like ideal op-amp, how to deal with the ideal op-amps, then how to deal with the transistors, that is the voltage and current equation of the transistors, diode connected transistors, and also the superposition theorem. So let us discuss in details and the way you need to work out these problems so that you can save the time and easily get the accurate result. I want to demonstrate it. So it was asked in the GATE 2017. First look at this question. First read the questions fully. In the voltage reference circuit shown in the figure, the op-amp is ideal and the transistors Q1 and Q2 up to Q32 are identical in all respects and have infinitely large values of common emitters current beta. So this point is very obvious here because this indicates that the IB, that current through the IB is 0 because large beta, so IB you can neglect. Collector current IC of the transistors is related to their base emitter voltage VBE by the relations IC equal to IS exponential, that is e to the power VV upon VT. This is the same diode equation except you don't have a here plus 1, so it is neglected, where IS is the saturation current. Assume that the VP shown in the figure is 0.7 volt. This is your 0.7 volt. Okay, and the thermal voltage, that is voltage equivalent temperature, thermal voltage is the 26 millivolt. So we need to find the output voltage in volt. First of all, you have two current. This is your I1 and this is your I2. So according to the questions, there are 32 transistors. If you leave this I1 transistor, that is Q1, so altogether you have 31 transistors here. So you can directly write your I2 is equal to, this is your current for the Q2, this is for the current Q3. So altogether you have 31 transistors. So you have 31 IS e raised to the power Vp upon Vt, right? So you can find out Vp is equal to I2 upon 31 IS, that is log of and Vt. This is just I did the taking the logarithmic, first divide the I2 by 31 IS, then taking the logarithm of the both the side, I found the these relations. Let's say this is equation 1. Similarly, for the transistors Q1, you can calculate I1 is equal to single transistor, so IS e raised to the power V. Let's say this is your VBE. So VBE upon VT. So you can calculate VBE equal to VT ln I1 upon IS. So there is two logarithm terms. So how you can reduce or cancel? Obviously you need to cancel the IS. So I can do one thing, VBE minus VP equal to, you just see here, log m minus log n is equal to log m upon n. So Vt, take the Vt common, then ln, this is your I1 upon IS into division of I2 upon 31 IS, that will be multiplied, that is 31 Is upon I2. So you have VBE minus VP is equal to, your VB minus BP equal to VT ln 31 I1 upon I2, or VBE is equal to VP plus VT log of 31 I1 upon I2. This is your equation 3. Now come to here. Now the concept of diode, diode connected transistor is over. Now come to the operational amplifier. See, the beauty of this question is they have given also their biasing voltage of operational amplifier. Okay, some people may mark the minus 15 volt or plus 15 volt, so that's why they have also given the values. So this is a trick to fool you, in the simple term I can say. So until unless you prove the transistor is in saturation or plus VB saturation or negative saturation or positive saturation voltage will appear, you just assume that your operational amplifier is operating the linear region, and you know that if it is operating in the linear region, that is this terminal voltage V minus and this is your V plus are equal because or negligible. That means this is your same VBE. I am assuming that your operational amplifier is operating in the linear region, right? If both these potential, I mean to say these potentials are equal, so you can just put a KVL around this loop. So what you will get? 20 I1 minus 20 I2 equal to 0. That means I1 upon I2 equal to 1. So put these values in 3. So you get VBE is equal to VP plus VT ln 31. Equation 4. Now one part is over. Now look at this. How we can relate this VBE with the V out. Just think of, here is the V out, here is the VB, here is the VP, 3 voltage. Just simple concept I want to make you understand. Let's say this is your R1, this is R2, this is your V1, this terminal voltage, and this is your V2. We need to find this voltage. Let's say V0. So you just remember that you need to find by superposition theorem. Assume any voltage V1 0, then find V0, then assume V2 0, find V0, then add together. For that case, you will have first assume that V2 0, so you have R2 upon R1 plus R2 V1. Assume V1 0, so you have plus R1 upon R1 plus R2 V2. This is your V0. You just check here. Here is your V0. Here is the VBE. Here is your VP. So your VBE is equal to, first assume VP 0. So 5 upon 25. 5 upon 25 V0 or V0 plus assume the V out 0. So you have 20 upon 25 VP, which is equal to 1 upon 5 V0 plus 4 upon 5 VP. So V naught is equal to 5 VBE 5 VBE minus 4 VP, and we have already calculated what is the value of VBE. So 5 VP plus 5 VT ln 31 minus 4 VP. So you have VP. So your V naught equal to VP plus 5 VT ln 31. So your VP equal to 0.7 volt plus 5 VT is your 0.026 volt, and ln 31 is equal to 3 point, just use simple calculators, 434, and finally you got the V0 is equal to 1.1464 volt. So this is the all about. So see the intertwined concepts in a single questions. First concept is the diode equations. Eliminate the IS. Second concept is the Opamp ideal. So find out the relations between this current. Third concept is the superpositions. Ultimately, your aim should be finding the output voltage. So you should relate the equation which involves the variable given. So I found that that equation is your V0 equal to Vp given, 5 Vt given, and ln 31, that is your I1 upon I2, that relation also we have just calculated. So this is the answer. Hope you understand, and you can attempt similar questions based on the this intertwined conceptual things. Thanks for watching my video.